Okay, question number 4. All right, so this was that central limit theorem section of the book, and you're like, okay, you're not going to ask me theory. So there was this weird thing where we have these blocks of 16 numbers, and then you had to do some stuff with it. Okay, so what this is a combination of here's a block of numbers, do some stuff with it, and the actual theory written in question B and question D. All right, so my plan is I take the entire block of numbers and I do one variable stats on it. So I go into like stat, edit, and then in list 1 I put all 16 numbers. So 0, enter, 1.5, enter, 2, enter, 2.1, enter, 1.5, enter, and so on. I put in all 16 numbers. Then I say quit to get out, stat, calc, one variable stats. Okay, then I start answering questions. The mean of the means, these were the means, so doing one variable stats on it, you just took the mean of those means. Okay, and the mean of the means turned out to be 2.8. Okay, so I one variable stats, the entire block, and I wrote down X bar right there. Same, larger, or smaller. What can you say about the mean for the entire population? What's the same? That's the whole point of being able to do statistics. We'll never get the entire population, but we can get the same mean as the entire population by doing statistics. Standard error of the mean. Okay, well, we did kind of like the mean of the ranges and stuff like that, but this is the standard deviation of the means. They call it standard error of the mean, but it doesn't require some new calculation. Okay, back up here, I still have one variable stats on my screen, and I've got sigma and I've got S right there. Okay, now I want to use sigma for this one, and the reason why I want to use sigma is this was the thought experiment. We did everybody in this population of 4 people, so I need to be using sigma and not S. Okay, I am the U.S. Census when the population is only 4. Okay, and my calculator says 1.19. I did not go and get a new calculation here. I'm still looking at the exact screen I did when I did that. What can we say about the standard deviation of the entire population? So you got to read it in the correct direction. The entire population is larger. If it has a really spread out bell, then doing statistics on statistics brings in that standard deviation. It sucks it in. So the entire population is the large standard deviation. What can you say about the standard deviation of the entire population? It is larger than the skinny little standard deviation right there.